Okay, so welcome back. We're going to continue. If you watched the last video, you know that we went through the first page, we went through definitions, and we talked about this diagram right here, where we had two parallel lines being cut by a transversal, thus creating 8 angles. And we talked about the relationship between these 8 angles. Okay, now we're going to prove that a lot of these angles are actually congruent. So the vertical angles theorem. Now, let's go back up to the diagram and talk about what vertical angles were. So vertical angles, so 2 and 3. These were vertical angles. Okay? Now, the vertical angles theorem, what this is going to ask, it says that, first of all, let's make a diagram. So I'm going to draw a diagram. So here's a line, and here's another line. Okay? Now what we're going to do is we are going to prove that vertical angles are congruent. So let's call this line A, call this line B. Okay? So lines A and B are intersecting lines. So lines A and B. The theorem, lines A and B intersect. They intersect, and we want to, let's call these angles 1, 2, 3, and 4. Okay, prove angles 2 and 4 are congruent. Now this symbol right here, it's an equal sign, and we draw a little wavy line above it. This means congruence. So actually, if you wanted to come back up here, definition of congruence, we show congruence through this symbol right here. And again, congruence means that they are the same shape and size. So basically, we're just trying to prove that these two angles are pretty much the same. Okay. Now we're going to use a 2-column proof here. So I'm going to make a list of. I'm going to separate this a little bit. Actually, you know what? I'm going to move this sentence right here above over here. It gives me more room. So if I'm going to make a 2-column proof, we need 2 columns. I'm going to make my statements over here, my reasons over here. Now always start with what you're given, okay? Now what we know is that A and B intersect. And this is given. Okay? We know that they intersect. Now, what we also know is we have some linear pairs, right? Linear pair means that they are supplementary angles. So I know that angle 4, so this angle right here, I know that this angle, and I also know that angle 3, so angle 4 and 3, if you add them together, the measure of their angles equals 180. So I'm going to say that this is measure of angle 4 plus measure of angle 3. If you were to add them together, you'd get 180 degrees. Now the reason why we know this is through the linear pair postulate. So through linear pairs. By linear pair postulate, we know that this is true. We also know that angle 2, that measure of angle 2 and measure of angle 3 will also give us 180 degrees because, again, they are a linear pair. So this pair of angles right here. So measure of angle 3 plus measure of angle 2 will also add to be 180 degrees. Now, again, what we're trying to prove is that measure of angle 4 and measure of angle 2. So the vertical angles, we're trying to show that these will be equivalent to each other, that they are congruent, okay? So here's how we can do that using these two lines of argument. So I know that measure of angle 4, let's say I subtract measure of angle 3 from both sides. So this would be 180 degrees on the right side minus measure of angle 3. And we can do that through the substitution property that we talked about last time. Similarly, I can do measure of angle 2. I could subtract measure of angle 3 from this side over here and subtract it to the other side, and I get measure of angle 2 is equal to 180 degrees minus measure of angle 3. So look at this right here. Measure of angle 4 is equal to, oh, we did this by sorry, I didn't mean to write substitution up here, it should be subtraction. So through subtraction. And this one was also through subtraction. So we know from these last two statements that measure of angle 4 is equal to 180 degrees minus measure of angle 3. And measure of angle 2 is equal to 180 degrees minus measure of angle 3. So they equal the same thing, right? So right here, so measure of angle 2, we have that right there. Measure of angle 3, right here and right here. And measure of angle 4 was right here. So what I could do, so here's measure of angle 4. The measure of angle 2, since they're equal to the same thing, I could substitute this right here for measure of angle 2. So hence measure of angle 4 is equal to measure of angle 2. And that's through the substitution property, right? We learned about that last time. Because look, measure of angle 2 is 180 degrees minus measure of angle 3, so I can substitute that right here. So measure of angle 4 will equal measure of angle 2. And because their measures are the same, by definition of congruence, measure of angle 4, or we can just say angle 4, is congruent with angle 2, which is what we were trying to prove. So, or I guess we could say so that's by definition of congruence. We can state that because they have the same size, same measure, then they are congruent. And again, the proof was to have measure of angle 2 congruent to measure of angle 4, but through the reflective property, I think it is, it would just still be the same. Measure of angle 2 is equal to angle 4, so still the same thing. Okay, so we just proved that vertical angles are congruent. So 4 and 2 are congruent. Now, through similar reasoning, through the exact same reasoning, just using different angles, we can prove the same thing for 3 and 1. 3 and 1 will also be congruent. But the good thing about proofs is that we make these proofs so that we can use it generally. So now we can apply this, we can show that all vertical angles are congruent. Which is why we do proofs in the first place, so that we can prove things generally for all examples, not just one. So that is this first proof that we had to prove, vertical angles. So go ahead and jump to the next video where we talk about alternate interior angles.